Hi guys, so in this video we're going to be discussing about stacks. So what do I mean by stacks? Have you ever heard the English word stack? I'm pretty sure you've heard it. It just means keeping things on top of each other. That's what stacking means, right? That's exactly what this is. So the video is actually over, but I'm going to explain it a little more deeper so you get a grasp in it. So the example I'm going to take in this video is a stack of books. So there's nothing on the table right now. I'm going to add a book to the table. Okay, so there's one element or one book in the stack. I'm going to add one more. So now, okay, for a better understanding, I'm going to add one more twice. So basically two more books. Okay, now I want to read this book. Can I just take it out like that? No, the whole stack will collapse. So that's what a stack is. All you can do is just meddle with the topmost book. If you want to read this book, take all the books on top of it one by one, like this, and then you can read this book freely. Yeah, so all you can do at any point of time is just meddle with the topmost element of the stack. So okay, so now we can clearly see that there are only two possible operations in a stack. You can take out the topmost book or add a topmost book. That's all you can do. So taking out the topmost book is called popping, and keeping it on top is called pushing into the stack. Popping out of the stack, pushing into the stack. That's the terminology we're going to use in computer science. The most challenging part in the computer science implementation of a stack is that you should always keep track of what is the topmost element. Now see, I'm popping out of the stack, as I said. Now the topmost element of the stack changed. The second-most top is now the topmost. Yeah, so you have to keep a variable that always keeps track of what is the topmost, and if you fail at any point to keep track, you'll have like bizarre consequences and the whole thing will go bananas and you'll get a lot of errors and stuff. I guess that's all. Let's go to the computer science incline section. So hi guys, welcome to the second section of this video, and in this section we're going to translate what I said in the previous section. So let's see. So the prerequisites for this section is the basic C programming knowledge and a basic knowledge of pointers and structures, and you're good to go. And now let's visualize arrays as stacks. How do we usually visualize arrays? Like this, right? Horizontally, right? So this is what I call the usual way. Now this way is way more easier to consider a stack, because it feels like I'm putting numbers on top of each other, like 1, 2, 3 and 4 and 5. So this is how we're going to interpret an array from now on to make stacks an easier way. So let's go. So this, I call it the stack way. Let's go. Okay, so the model of a stack, what do I mean by that? Model of a stack is basically what do I need to create a stack? I need some space to put the numbers on, or the characters or strings or the books like in the previous section. So that space is an array in this case. So that's a 5. So this 5 can be any number based on your convenience, based on your use, can be any number. Now, and a top variable which keeps track of the topmost elements index. Like let's say the elements are from 0 to 3. That means the topmost element is in the index 3, and this top element is this top variable is gonna hold this 3 to show that the stack ends there. I mean the stack starts there basically. Okay, so let's go to the next one. Okay, so keeping track of top. How am I gonna keep track of top while I'm pushing or popping? Oh shit, sorry, pushing or popping, that happens, doesn't it? Okay, so we're gonna fill all these blanks now. Yep. So one assumption we're gonna do is that the 0 is the ground. Like in the previous section, when there were no books, there was only the table, right? So like the table, the zero block is going to act as a table, and the stack is going to be stacked on top of the ground. That's all makes kind of sense, right? Yeah. Okay, so when the stack is empty, there's only ground, so top is going to hold 0, which is ground. Now let's say I'm pushing another number into the stack. Let's say 5. I don't know why I chose that number. So top becomes 5. Actually in the opposite order, but okay. Okay, now I'm pushing 6. The actual order in which top is going to change is first top is going to become 2 and then 6 is going to be inserted. Okay, so remember the order, remember the order, remember the order. That's all I'm going to say. Now I'm adding 25 just to show that it's random. First we increase top and then put 25. I'm adding again 32. We increase top and then 32. Now notice, if I'm trying to push some random number, some 100, I'm trying to push 100 into this stack, it's already full. There is no more space left for pushing in. So this situation is what it's called overflow. So this overflow can be easily checked. When top is already 4, that's all, it's overflow. So every time we push something, we're going to check whether top is already 4 or not. And then if it's 4, we're not going to make any changes to the stack. We're just going to return the stack as it is. If it's not 4, then it means the stack has room for pushing in. So we're just going to push in normally. So now listen to this clearly. The popping method is kind of different and vague, but it makes sense. Okay. So let's say I want to pop this 32 because all you can do is just pop 32. You can't pop 6 out of nowhere because it's a stack. Okay. So I'm going to pop this 32. The only thing I'm going to do is just decrease top. That's literally it. So basically here what I'm saying to the system is that top is equal to 3. It means that the topmost number is in the index 3. Above it, whatever number there is, it's just junk. So if I push some 100 now, it's going to check for overflow and it's 3 only, so it's not overflow. So top is going to become 4. And now 100 is going to be overwritten here. You get it? So it doesn't matter whether there are numbers above or not, it's going to be overwritten anyways, and we're not even going to access those numbers. So it doesn't even matter. So I'm popping. Popping just means that I'm going to decrease the value of top. That's all. That's the only thing I'm going to do in the process. I'm popping again. I'm popping again. And I'm popping again. Now the stack is empty according to the system, right? Because everything that's above is just junk. So the stack is empty. So now if I pop again, it shouldn't do anything, right? If I pop an empty stack, it's called underflow. And that also can be easily checked. If the top is 0, it's underflow. If top is 0, there's only ground and you can't pop the ground obviously. So it's 0. So every time we pop something, we're going to check for underflow, which is top equals 0. And every time there's an overflow, you're going to check for top equals 4. Top equals 4 is a specific thing for vals of 5. But let's say it's vals of some random number. Then we're going to check top of that random number minus 1. You understand? Like, let's assume that it's int vals of x. Then we're going to check top equals x minus 1. But underflow always remains the same. It's always going to be 0. So this is how we keep track of top. And in the next video, we're going to implement stack in C language. So see you later. And thank you for watching. All the best.